This video is going to be over factoring polynomials, specifically lesson 6.6 out of our textbook. And this lesson is titled A General Factoring Strategy. So to help us with this general factoring strategy, we're going to go through several examples. This video is going to be broken down into 3 different videos. So for this first video, we'll go through 4 examples, and then the next video will cover 3 examples, and then whatever examples are left we'll cover in the third video. So with these examples, we'll be talking about how do we know where to begin. And essentially, the first thing to do with any of these problems is to make sure that if there is anything that can be factored out of all the terms, to factor that out first. So starting with our first example, number 2, that actually is the first step we need to take. So we have this polynomial, 2y to the third minus 10y squared minus 28y. And the GCF of all 3 of these terms is 2y. So we're going to begin this problem by factoring that out. And so now we're left with y squared minus 5y minus 14. And again, you can always go back and double check that you factored it out correctly by saying, okay, does 2y times y squared give me this 2y to the third? Yes. Does 2y times this negative 5y give me this negative 10y squared here? Yes. Does this 2y times this negative 14 give me the negative 28y? Yes. So this would be correct so far. So now we can go through and do our strategy of, well, this is in the form x squared plus bx plus c. So we don't have to worry about using the AC method because there's only a coefficient of 1 in front of this term here. And so we're going to go through and use what we had called our x method for organizing our work. So negative 14 is going to be on the top. Negative 5 is on the bottom. And again, we're asking ourselves, what multiplies to give me a negative 14, but then adds to give me negative 5? Because you're multiplying to get to a negative, that means the signs here are both positive and a negative. So we have one of each. The combination that we want to use are going to be 7 and 2. 2 is going to be the positive and 7 is the negative. And again, 2 times negative 7 gives me this negative 14, but then 2 plus negative 7 would give me the negative 5. So this trinomial here is going to factor into, still have the 2y out front, but this is going to factor into y plus 2 multiplied by y minus 7. And this would be our factored polynomial. For the fourth example, this is another one that is in the form x squared plus bx plus c. So we can go ahead and just use our x method. So we can use this to help organize our thoughts again. So writing this off to the side, we have 3 on the top, and also a 3 on the bottom. And again, trying to ask yourselves, what multiplies to 3, but adds to 3? And it's multiplying to a positive 3. So that means they both have to be positive because we also are adding to a positive 3. And the only factor pair for 3 is 1 and 3. There's no way to combine these to make positive 3. So this is an example of a prime polynomial. So sometimes that happens with these where there's nothing you can do to break it down into different factors. And so number 4 is prime. Then our next example, we have this polynomial here, which has 4 terms. Typically when we see 4 terms, that is hinting that we're going to end up using that factoring by grouping method. But before we even get to that point, we do want to make sure that, again, if there is a GCF between all 4 of the terms, that we factor that out first. In this case, there is no GCF between all 4 of these terms, so we're going to get started by doing this factoring by grouping. I'm going to go ahead and rewrite this so that I write it as a plus negative and a plus negative to help me with this whole factoring process. So I'm going to have 2x cubed plus 5x squared plus a negative 8x plus a negative 20. I'm going to go ahead and group the first 2 terms together, and I'm going to group the last 2 terms together. So now that I've grouped these 2 sets, we're going to look at each set and figure out, okay, well, what's the GCF of this first group? The GCF of this first group is x squared. So I'll have x squared out front. We're left with 2x plus 5. And again, just like the previous problem with number 2, you can always go back and double check. Does x squared times 2x give me 2x to the third power? Yes. Does x squared times 5 give me this 5x squared? Yes. For this next part, again, your goal with factoring by grouping is that you want this expression here to match this expression over here so that you can factor out that from both of these terms. So if we need this to be a positive 2x plus 5, we're actually going to end up factoring out a negative 4. Because negative 4 times a positive 2x would give me this negative 8x. And then negative 4 times a positive 5 would give me this negative 20. And then we just have one more step. Actually, we're going to have a couple more steps looking ahead a little bit. We're going to factor out this 2x plus 5. So we'll go ahead and do that. And then we're left with this x squared and then this minus 4. The reason I said, actually, we're not done is because this right here is a difference of squares. So all of this, those strategies and those different patterns, those special factor rules, all come back into play within this section. So this x squared minus 4, as a reminder, our difference of squares says x squared minus b squared equals a plus b times a minus b. So we can think of this x squared minus 4 as still this 2x plus 5 out front. We haven't gone anywhere with that. But this x squared, that obviously is just x squared, but then this 4 we can think of as 2 squared to help us match up with this pattern. So this right here is going to end up breaking down into, again, 2x plus 5, and then x squared minus 2 squared, a squared minus b squared. This is going to be the same as x plus 2 times x minus 2. And now we have completely factored this polynomial. The last example for this video is number 12 out of the book. It says 6x squared minus x minus 7. This is a trinomial, but it is of the form ax squared plus bx plus c. So with this one, and again, we can't factor anything out, so that's always something to double check too. I forgot to mention that for this problem. There is no GCF between all three terms, so this is of the form ax squared plus bx plus c. So we're going to go ahead and use that AC method. So again, the AC method says we're going to take the a value, multiply it by the c value, and that's what we're going to use at the top for our x method to help us kind of organize our thoughts here. So negative 7 times 6 would be negative 42, and we're trying to find a combination that will add to give me negative 1. So again, we're trying to multiply to negative 42, but then add those two numbers to get to negative 1. So if we think about all of our different factor pairs for 42, the one that's going to have a difference of 1, and the reason we're doing a difference is because this is a negative. So to multiply to get to a negative, you're going to have a positive and a negative number, which means you're going to end up subtracting them. That combination is going to be 7 and 6. 6 is our positive number, and 7 is our negative. 6 times negative 7 would be negative 42, but 6 plus negative 7 gives us the negative 1, which is perfect. So with this AC method, we can't just say it's x plus 6 times x minus 7. That's not where we can end because we have a value in front of x squared besides 1. So what this helps us to do is to rewrite this so that we can do factoring by grouping. So we're going to have 6x squared plus 6x minus 7x. So instead of writing minus x, we write it as plus 6x minus 7x minus 7. I'm going to go ahead and rewrite this so that we have plus negative 7x and plus negative 7 on the end, just to make it a little bit easier to keep track of those negatives. I'm going to go ahead and group the first two terms together, and I'm going to group the last two terms together. Focusing on those groups that we just made, the GCF of this first group of 6x squared and 6x is 6x. So now I'm left with x plus 1 on the inside. Plus, and again, our goal is to get this x plus 1 over here as well, so we can factor it out of both. So we're going to end up factoring out a negative 7, and then I'm left with x plus 1, which is perfect. So now we're going to factor out the x plus 1 from both of these terms, and then I'm left with 6x plus negative 7, which we'll write as just minus 7. And then that is as far as we can go with this question.